color is an illusion.
Right.
Color is not really there. It's like if you look at this from an
color's not real.
It's not real.
Right. Neither are birds.
That's also a theory I read a lot of times on the internet. Like, what if we use diamond surface?
What's the German word?
Oberflächenaktivität.
Okay.
I think.
You could be making it up. I have no fucking idea.
You know how NVIDIA is. They would never accept a mistake.
Okay, I'm joined by Roman, aka Der Auer, and Joe. Do you have a Der Auer equivalent name yet? Have they assigned you one?
JR23 when I was a modder.
Okay, all right. So you have a bunch of stuff at Computex. On the engineering side, there's a lot to talk about. You have a Noctua Edition WireView. You have a new Thermal Paste, right? Duronaut Pro.
Yes.
You've got these 4 different coatings for plates that we'll look at. Then new fans.
It's the first fan we ever made, right?
Yeah, the direct eye diamond.
Direct eye diamond block?
Yeah.
Yes.
Before that, this video is brought to you by ID Cooling and the Frozen A720 cooler. The A720 air cooler performed well in our testing last year. The A720 is a relatively high-end, dual 140mm air cooler with 7 heat pipes. We found the use of larger fans can be beneficial to acoustic performance given the thermals, although you'll want to check your case for compatibility given the taller nature of the cooler and its fans. ID Cooling uses an all-black look for its A720 and includes mounting hardware for all modern sockets. Learn more at the link in the description below. You already have WireViews out there, but is there any difference other than just the fan?
There's a lot of things that are different. Like, I will just go over the electrical part real quick because the base is the same WireView Pro 2 that we're already selling. So it offers the same functionality like per pin sensing, where we know it is detecting a lot of issues.
Yeah.
We have that daily on our Discord server where people like, I bought the WireView Pro 2, my pins are looking bad. Or even people, that's the most scaring part. They install it, things look great. 2 months later, suddenly it's bad.
Do you think NVIDIA, so technically speaking, I guess, the 12 high power spec, it's not only NVIDIA, it's on AMD cards now as well. And they're not the only ones to develop the spec, but they are driving the use of it, obviously.
Yeah.
Do you think, gut feel, that they're going to change at any point? Like for the next,
I don't think so. I mean, from my own personal perspective, they should change it. Even if it would mean we can't sell this anymore. But like from my personal perspective, like from an engineering perspective, this is not a great approach.
Yeah, well, and because I feel like NVIDIA has so much pride in the stuff that they do. I have a hard time seeing them changing unless it's...
You know how NVIDIA is. They would never accept a mistake. They would never... They might in a generation or two be like, oh, we found a better connector, and then just go back to 8-pin. But they would never admit that they made a mistake, right? But I don't think we will see a move back, at least for next generation, because if you think about it, how early 12-volt high power was introduced prior to the 40 series, we would probably already see, I don't know, specs leaked, PSU manufacturers would be working on something, which I don't see, so I don't think they will move away from it.
Right. I think also with 12-volt high power, the big thing they were trying to do, at least as they advertised it, was reduce the PCB size to maximize flow through and cooler area. And so on the FE they do that because I guess you don't need as many, you don't need 4 8-pins. I kind of doubt if they go back to 8 pins just because I don't think they want to give up that thermal change.
If you look at this from an engineering perspective, the logical solution would be to go with one big wire that carries 12 volt and one big one that has...
the wall.
Not like that, but you can have like this thing that's always on the internet, like the XT90 or how this is called, like just because parallel pins will always have this issue. You can't fix it.
Is there a downside to doing just
a single one?
Yeah.
No.
Okay.
It's just bigger and not as easy to use.
Yeah.
It's not that easy making. It's not that easy making a super flexible one. But from an electrical standpoint, the logical solution is go with a single, very thick wire.
Right.
And you solve all the issues immediately.
Okay. All right.
So I just wanted to say that electrically, it's based on the WireView Pro 2, same functionality for measuring and everything else. And then Joe can tell you the magic he did.
Right. So the first thing, the original Pro 2 has a 30mm fan. And Noctua's smallest fan was a 40mm fan. So fitting that inside was one thing. The best way we could do it was with this fan, which has no frame at all.
Right.
So that just reduced the diameter by about 2.5 millimeters, which we really needed because it fits inside the original connectors which join the two boards. We had to modify this PCB to fit the fan and hang it out very slightly, so the frame is about 7 millimeters bigger than the original, just to find space for the fan. And then we've added this heatsink to it, which has a thermal pad here against the base of where the connector is soldered on, so it cools all the traces and therefore the pins.
Does that make it easier to run passive?
So it should run a lot more power before the fan needs to come on, and then when it does, it's a much bigger fan, much more efficient.
Acoustically, do you guys have any numbers or anything like that, or?
Not yet.
No. Okay.
Not yet, because we haven't had it in Germany yet.
Subjectively, I guess. Like if you were to subjectively qualify the noise profile.
I mean, I think at 600 watts it will run passively. So under normal use, in most cases where there's some airflow, this will be 0 decibels.
Right.
It's also not only about decibels, right? It's the profile. The profile. Yeah. The small fan is more like a high pitch thing, a bit more annoying. This one just sounds a lot better.
Yeah.
Like it's incredible how much air it's moving at the just subjectively lower noise.
Noctua helped us to optimize the fan grill, so we have the acoustically most efficient fan grill for the size of the hole.
What was the development time on this?
We've been working on it for about 2 months.
This is very impressive for a lot of reasons.
Yeah, it started when I was making a Noctua build for my YouTube channel, and then our sales, or COO, he said, why don't we ever make a Noctua edition? And I said, that's a good question. So reached out to Jacob, and we said, what about Noctua edition for WireView Pro 2? He liked the idea, and then it just...
Are you already in production?
Yes.
Okay, cool. Wow, that's very impressive.
Well, partially. Yeah. It's still a lot of things to do, but should be maybe 3 months from now.
For launch?
Yeah.
Cool. So roughly 5 months from start to shelf. Is that the fastest you've ever done a product?
No.
What was the fastest? What was the product?
The fastest product we ever made? That is a very good question.
Don't look at the fan in the graphics card.
No, I mean, I think especially when there are CPU launches, I think the fastest I personally made was the AM5 delitter.
Oh yeah, right.
Maybe like 2 weeks.
Yeah.
And just 2 weeks full time, and then going over revision with in-house machining.
I forgot the delitters you were pretty quick on those.
You have to be.
Yeah.
I sometimes have like 4 weeks from getting a CPU to CPU launch.
Right.
And then you have to be super quick. That's also why as I said again, it's not visually appealing, but just functional.
Right. So we visited the factory previously, and in the time since, you've ordered but haven't yet received, you said, your most expensive machine yet?
Yes.
What is that?
It's a PVD coating machine.
Okay. What does that stand for?
Physical vapor deposition.
Okay.
And we basically want to move away from nickel plating on water blocks. For multiple reasons. We figured out over time that it's not as gallium resistant as people thought. So let's say 10 years back, everybody was like, hey, if you want to use liquid metal, it just has to be nickel plated and it will be fine. Now we know that's partially true. It just prolongs how long you can use it, but in the end it will still be a problem. It's more like that you could call it an alloy that's building.
Okay.
So you have a gallium nickel compound that's building up. That's the same thing that happens with the copper. So you have like gallium copper, and that stuff has very bad thermal conductivity, and it just hardens. That's the main issue. So when people they look at liquid metal on a nickel layer and it looks like hard, then they're like, oh yeah, the liquid metal dried out. That's not what's happening. It's like just building a compound with the nickel, and then it hardens.
Okay.
Has bad thermal conductivity, and that's how you lose performance.
So in other words, reapplying new liquid metal, it sounds like doesn't solve.
Yeah, you just apply it on top, and then you improve it again, but you already still have a very bad layer underneath.
Okay.
And that's not a great solution from a technical perspective. Those are different types of coatings we want to use in the future for water blocks. We want to move away from nickel plating as much as we can. These are better in all aspects, like from corrosion perspective and also especially from the thermal performance. This is a dual layer thing, so there's a metal layer underneath and then there is an oxide layer on top.
Okay.
And this oxide layer is very thin and that's what's causing the different colors. And
what causes the gradient, like the green, purple, bluish?
I mean, it depends how thick the layer is. So if you have it like 5 nanometers or 10 or 15 nanometers, then it's refracting the light in a different way. That's what I said earlier. It's like color is an illusion.
Right.
Color is not really there. It's like if you look at this from an
color is not real.
It's not real.
Right. Neither are birds. Is there why does the thickness change? Like you're talking about nanometer thickness.
The distance it's away from the target when you make it.
So I guess maybe we should go through that. What's the when you say target, like walk me through the manufacturing process.
So a PVD machine is like a big empty chamber. So on one side you have whatever you want to work on, like the copper pieces.
Yeah.
They are in a carousel. They're spinning in multiple axes, so you can hit all the surfaces. Then there's nothing in between, like perfect vacuum. You heat this up to, depending on the material, like 500 degrees Celsius. And then on the other side you have what they call the target. It might sound a bit weird because you might think this is the target.
Right, yeah.
But the target is the metal base you're starting with, and that's getting hit by, could call lightnings, right?
Okay.
And the lightnings are then releasing metal ions, and they will stick to the surface.
Okay, cool.
You can combine this with, like, you can have multiple different metal sources or targets, and then you can have process gas in between. And then you can come up with a lot of different coatings. This is a carbon coating.
So is this the same as you see on like some drill bits, I guess?
Yes, so sometimes you have like end mills that are black.
Yeah.
And that's usually also done to just improve the friction. And the good thing is that this carbon is also very good when it comes to anti-corrosion, because the one issue we have with water blocks is that if you have a nickel layer, it's a metal layer. And if you have other metal ions in the loop, they can stick to it. And that's what's happening a lot. People these days are using, most of the time, clear fluid. They moved away from colors, which means
because they're an illusion.
Yeah. But it also means that these days you can see much more of the corrosion that's happening inside. If you think about it, you have like a radiator that has copper, brass, and brass is like copper and zinc. And you already have a material mix, and these kind of
solder,
metals.
I think historically solder has sometimes posed a problem.
Yeah,
well, so.
And that could always stick to the nickel, and there's nothing you can do about it. That's what we also learned. A lot of people, when they have the water block and it has like a brownish layer on top, they think like the nickel is gone, the nickel is damaged. But in reality, you just have other metal ions, most of the time copper, that just stick to the surface of the nickel on top.
What's the impact on your price, I guess, like MSRP wise?
The pricing will not change much. The difference for us versus an external supplier, the nickel coating, is not much different. These layers are super thin. In typical nickel coating, we're using in the industry between 10 and 20 micrometers, whereas these can be like 500 nanometers to 1 micrometer.
Yeah.
And it's not only that, but also the thermal conductivity of this material is almost 200.
Is most of your thermal improvement coming from the reduction in the layer thickness, I guess? It's
a reduction and also increase of the thermal performance.
Okay.
Yeah.
So what is this, and why diamond?
For direct die cooling, we are, when it comes to performance, just limited by how much like fin density can we pack into the block. The power density of the chips is very high these days, and we can't really improve it further just from the engineering perspective on how we make the block. You can find half degree here and there, but
which is a lot.
Yeah, in the water cooling space.
If you can get 1 degree, I feel like that's kind of a lot at this point. But
that's also a theory I read a lot of times on the internet, like what if we use diamond? Because it has very high conductivity. This is a so-called CVD diamond, chemical vapor deposition. Basically a lab-grown diamond that's grown like on a seed crystal with just out of a chemical vapor.
Okay.
So that's how it's grown, not under pressure like a natural diamond, but it's physically the same. It's just carbon, but in a like perfect structure, so it has very high conductivity, about 2,200 watts per meter Kelvin. which is 5 times as much as copper.
The copper is like 400 plus or minus,
400,
I guess.
Yeah. So the theory behind it was that you stack this on top of the CCD, in this case of an AMD CPU, and then this just spreads the heat a bit more in X and Y direction.
And then you're leaving the I/O die normal, right?
Yeah.
I guess is that
for
just
cost
copper?
Reasons.
Right. Yeah. Is a diamond that size expensive, Roman?
Yeah. I mean, this size is about $250.
Okay.
To make a single one, so
Right.
that means that just.
And you need 2 of them.
You need 2. You can see it's translucent, but because it's pure carbon, liquid metal does not stick to the surface.
Okay.
That was one of the biggest challenges. So we had to find a way to metal coat the diamond. So this is a metal coated diamond to be able to have the liquid metal stick to the surface.
What is it that dictates whether it can stick or not?
It's I think.
Like, is it a bonding or is it a?
In German, I would if I would translate it, it's like the activeness of the surface, like how chemically active is the surface.
What's the German word?
Oberflächenaktivität.
Okay.
I think.
You could be making it up. I have no fucking idea. So, all right. As long as we don't make you say turbomolecular pump again. That was a challenge last time.
I can't handle that word.
Is this purely an engineering exercise?
Yes. The first testing we did, we saw between 3 to, on the peak, 6 degrees Celsius better testing.
6 is a lot.
Yeah, but...
how much money for 6 degrees?
Too much.
Yeah.
I mean, this block would cost over €1,000, like
Yeah.
1,500 or something. I don't know.
Right.
Yeah.
So mostly engineering exercise.
Yeah.
Did you learn anything useful from it, like for other products or any R&D uses or anything like that? Just fun.
The metal layer for the carbon actually helped us, because that's something we're also using on this.
Okay, this is where Joe will jump into it. You've got, as you were telling me, these were kind of your attempts, right? Your early.
Yeah, when you visited the factory, you saw already that we were working on fans, right?
Yeah.
So it's like 3 years ago, we said, fans would also be cool. The goal was to have a fan that has RGB and has similar performance as the NFA12 from Noctua.
G1, I guess.
G1, not the G2.
Right.
G2 didn't exist at that time. So that's also what this one can do. Same performance as NFA12. The concept of this one was using a full aluminum metal frame, so it doesn't use any plastic in the frame itself. It's extruded and then CNC milled.
Keep rigidity, I guess.
Yeah, so it doesn't flex at all, and it has a very thin material on the sides to just maximize blade diameter.
Right.
To just somehow be able to compete with the NFA12.
You've just got Type A's, which I don't think I've seen on a fan before, other than like the type you plug in on a desk, right? So
yeah.
So what's the deal with?
We wanted to have a daisy chainable fan, and by the time when I started working on it, the question was, do we go for like a proprietary connector like most?
Yeah.
Or do we just look in what is existing and what is cheap?
Proprietary sucks.
And USB-A is such a high volume that it's probably the cheapest connector you can buy.
Not proprietary either.
These initial ones, they actually have 5 PCBs. There's one in every corner.
Oh wow.
There's one under the hub, and they're all linked with. There's so many wires in this fan. And it's taken up like a huge amount of space on the stator.
There's a PCB in each corner, is that what you were just saying?
Yeah. To mount the USB.
Yeah.
So the USB is very cheap, but then you'd solder it to a PCB.
And then make everything expensive again.
Right. Okay, got it.
So the new one is different in that it just has one solid PCB for the whole fan. So you can see the PCB running there, not wires. So these are very neat. They're very slender for the amount of power and data and wires going through each one. So a normal USB-A connection in directly, and then there's the most space possible available for radiator clearance. And then we also added this A to A cable to connect between fans.
Well, I mean, also, I guess a customer could probably just buy any cable they want.
Yeah.
It's A to A.
Any A to A cable, you can use any USB gear.
Right. Okay.
But A to A's generally don't exist in the USB protocol, so you can't just blow things up by connecting them to themselves.
Right. Yeah, that makes sense.
So just to make that clear, it's not a USB device. You can plug it to a USB port,
power.
Just power. It just will spin the fan. That's all it's doing. But it's not detected as a USB device. There is no microcontroller on it.
Right. Okay.
I want to make that clear.
Cool.
I also had to realize, going back to Noctua,
yeah,
how crazy their products are.
Well, I mean, like they spent like 8 years developing. I think it was the D15 G2.
Yeah, like the G2. It's mind blowing how good that fan is.
So for the Duronaut Pro, which is
it's a new paste.
Apparently substantially better based on this chart that starts at 6.05 and ends at 6.50. Yeah. Roman, I have one question. What has happened to you? You've turned into this is like pure manufacturer.
Yeah. It's, so this was presented to me, and I was like, this is like if I would go to a booth, this is the first thing I would criticize.
Have you considered it, well, but you want to criticize it because they could have started at 6.2, right? Instead of 6.
So I said for next year there's still room for improvement. So if you make a Duronaut Ultra or Extreme, and let's say it's 0.1 different, we can make this chart like this.
Yeah, can you do that?
Of course.
Okay, I need a good video thumbnail.
Yeah, and then
that would be great.
Then I can say it's this much better.
Right.
Obviously, right?
Yeah. Okay. Good. I'm glad you're learning the ways of all of the hardware manufacturers in this space. You're truly a real company now.
Thank you.
You're not just their Bauer the overclocker anymore.
I'm trying really hard.
I know. What's kind of the chemical difference from it?
It's chemically the same. It's a bit higher fill rate on the fill material, and the silicon oil was changed a little bit, and that gives you this type of improvement. It's also this is not too bad because it brings you towards how much room is there left for improvement, right? And we're talking here about 0.3 degrees Celsius.
Right.
And this is in a normal application that we measured on like 240 watts, I think it was measured.
Okay.
So there you just see there is not much more to do, right?
Does it take longer to make?
It takes longer to make, it's more expensive to make. We do it just because we can do it, and this will be, according to our own testing, the highest performing paste that you can buy. And that's also what our brand stands for, that even if it might not make too much sense, but we still want to offer the highest performance.
Is there anything we're missing here in terms of detail you wanted to share?
About the coating, I just want to highlight that we have one block that we showcase here. We will show more at our own booth. So there we will have like the different coatings also in the bigger version.
Cool.
And we are just also looking for feedback, especially the rainbow coating. It is also very good chemically, but we also wanted to know if people like this or not, so that we would be very happy to hear some feedback about the rainbow coating specifically. And then we will also offer them in different combinations, right?
Right.
Yeah.
I guess pricing on the Noctua Edition we didn't do. So what are you expecting for price, and then what's the non-Noctua Edition?
So the base is the WireView Pro 2, which we sell for 119 right now, euros. And the Noctua Edition will be 199.
Okay, 200, so about 80 increase.
Yeah.
And then all this other stuff, I guess, is everything... except for the Diamond, which I guess it sounds like not launching, right? Is everything coming out this year?
I mean, we're trying to still make the fan happen this year. Coating will be also end of the year. We're getting the machine in September, setup time, just getting the process to run, and then we're trying to have the first blocks with coating available end of the year.
Cool, sounds good. All right, well, I think we'll probably have plenty of other coverage. I don't know if we may film something separately, a discussion piece or something, so you all can check back for that. But thank you both for joining. Good seeing you again.
Thank you. Thanks for being here.
And we will see you all next time.